All right, so we're going to look at number 31 in section 1.2. So I'll bring that over here so we can see it. It says, when landscaping their yard, a couple budgeted $4,200. The irrigation system costs $2,400 and the sod costs $1,500. The rest they will spend on trees and shrubs. Trees each cost $32 and shrubs each cost $4. They plant a total of 33 trees and shrubs. How many of each did they plant in their yard? So looking at the question, the focus is how many trees and shrubs. So I'm going to make a note down here is trees, we don't know how many, and shrubs, we don't know how many. But together, we have 33. So I'm going to play the game. It's the same game we did with the mixing formulas. Is I'm going to say, hey, my trees, I want T. That'll be my variable T, trees. That means that T and the number of shrubs have to equal 33. So I will make my shrubs 33 minus T. And I add these two together, T plus 33 minus T, I get 33 back. So I know how many things I'm getting in an algebraic sense with the T in there. And I'm going to combine them together, but with money. And so there's a rate happening in here. We have rates in money all the time. The trees cost $32 per item. That's the cost of the tree. And the shrubs cost $4 per item. Like I said, I'm kind of writing all the stuff I know down here. If I multiply the number of trees I have by the cost per tree, I will get dollars. Dollars will be my end unit. Right? 33 items times $32 per item will give me 33 times 32. Now we know we don't have 33 trees, but just saying with the number of items going across. Or T dollars per item times this will give me 32 T in dollars. And so our units work exactly like they do for measuring. And I don't know why I'm calling them intoms. The word item looked weird on the screen. All right, so they have a total budget, which I'm just going to call total, of $4,200. They spend $2,400 on irrigation and $1,500 on sod all. No, on the sod. Sod it. No, on sod all. Sod on. So we can do this as an addition. We can add up everything they spend money on, and it's going to equal the total of their budget, because they're going to blow their whole budget on this. So the cost of the trees is $32 per tree times the number of trees. They're also going to spend $4 per shrub times each shrub, plus 2,400 plus 1,500 equals 4,200. And so we've taken each part and put it together into our longer equation. Our job now is to combine terms and solve for our stated variables. So 32t plus 4 times 33, 132, minus 4t plus, well, we can combine these together to 3,900 equals 4,200. 28t, combining our t's together, right, a negative and a positive, plus, let's see, 2, 3, 0, 4, 4,302 equals 4,200. So now I've got variable and numbers. And yes, I'm flying with my calculator in the background if you hear it pulling through. I don't expect you to do all these in your head. That's why we have calculators, and they're not too terribly expensive these days. 32, and then just double checking here. 4032. So I want to subtract 4032 from both sides. And I get 28t equals 168. Divide each side by 28, and they're going to plant 6 trees. But we also need to know the number of shrubs. So 33 minus 6 equals 27. 6 trees and 27 shrubs. Again, rates, dollars per item, are hiding in the background of these things. And we're finding rates per unit give us dollars. And then we get everything in terms of dollars. So knowing what we're doing with units, knowing how we measure reality and putting it back into our problems, helps us with where we're going to set things up on these. All right, I'm going to do 2 more problems in this section, and then we're going to look at section 1.3. If you have any questions, email me.